Okay, so today we're going to talk about the mean. And the mean is one of the ways that we have of measuring the central tendency or the middle of a data set. Now, we have some notation that we're going to have to talk about before we start actually calculating means. So let's get started. The first notational thing that we have to look at is lowercase n. So lowercase n is here. And lowercase n is the number of values in a sample. So when you get your data set, depending on whether that data set represents a sample or a population, you may be using either this lowercase n or the next one, notationally, that we're going to look at, uppercase n. But if you're looking at a sample, if your data set is representative of a sample, then we use lowercase n, and that's going to be the number of actual data values in the sample or in that set. So the next one is the uppercase n that we were talking about, and the only distinction between lower and uppercase n is the distinction between what that data set represents. If that data set is representative of the entire population of things that you're considering, then you use the uppercase n to represent how many values you have in that data set. But if the data set represents only a sample of the population under consideration, then you use lowercase n to represent the number of data values in that data set. Now, moving along, the next thing we have to look at is xi, x with a little subscript of I. Now, xi is representative of each individual data value. The I is a counting variable. I starts at 1 and counts all the way up to n, which is the size of either your sample or your population, depending on what that data set is representing. So the values of xi range from x1, x2, x3, all the way up to xn. All right? Those are the individual data values in your data set. Now, the next one is sigma xi. Well, that little E-looking thing, funny-looking Greek letter, that is summa notation, is represents the sum. So that's actually the Greek sigma, uppercase sigma, and it represents the sum of the xi's. So that sigma represents sum, and you see the little xi's. That means we're adding up all the xi's. And if you remember, the xi were the data value from the data set. So this sigma xi notation just means to add up all the data values from x1 all the way up to xn. So you can see that formula there. Sigma xi stands for x1 plus x2 plus x3 all the way up to xn. Alright, now we have two more little notation things to look at. The first one is x bar, and x bar is the mean of the sample. So if you have a data set that represents sample values, the mean of those sample values is going to be denoted x bar. That's just an x with a line over it. And the distinction between that and the next little notational thing, well, let's look at the next one. The next one is mu. That's a Greek uppercase m, I believe. That's the mu, and that represents the same thing as x bar, the last one. The distinction is x bar is what you use if your data set is representative of a sample, and mu is what you use when the data set is a population. So x bar is the sample mean, and mu is the population mean. So if you're using lowercase n, which is a sample size, then you'll be using x bar, which is the sample mean. If you're using uppercase n, which is the population size, then you will be using mu, which is the population mean.
Now the mean of a data set is equal to the sum of all the data values divided by the number of data values. Now if that data set is a sample from a population, then the number of data values is going to be represented by lowercase n, and the mean is going to be x bar. So in the case of a sample, x bar is the mean, and it's equal to the sum of the xi's over lowercase n. Now in the case where the data set represents the entire population, the number of data values is going to be represented or denoted by uppercase N, and in this case, the mean of that data set is going to be called mu, and mu is the mean of a population. So that is basically what we need for the formula for both x bar and mu. So now I'm going to calculate the mean of my original data set. So what I'm going to do is I'm going to represent each data value as a glass filled to a certain number of units. So for instance, x1 I'm going to represent as a glass filled with liquid up to 6 units tall. x2 I'm going to represent as a glass filled with liquid up to 7 units tall. x3 I'm going to represent as a glass filled with liquid up to 7 units tall. x4 I'm going to represent as a glass filled with liquid up to 12 units tall. And I'm going to continue this process all the way up to the 15th data value. I'm going to represent as a glass filled with liquid up to 25 units. Alright, now that I have all my glasses representing my data values, what I'm going to do is I'm going to empty all these glasses. I'm going to aggregate everything. I'm going to empty all these glasses into this big bowl. So I'm going to take the first glass, and as I'm doing this, I'm actually going to count to see how many units of liquid are in my big bowl. So I'm going to take x1, which is 6, and I'm going to pour it into my big bowl. And in this case, I will have 6 units in my big bowl. So now I'm going to take x2, 7, and I'm going to pour it into my big bowl. And now I have 13 units in the big bowl, the original 6 from x1 plus x2, which is 7. So 6 plus 7 is 13. And I'm going to continue this way. x3 I'm going to add 7, so I'm up to 20. x4 I'm going to add 12. x5 I'm going to add another 12. Then x6, x7, x8, x9, x10, x11, x12, x13, x14, and finally x15. So once I've aggregated all of these glasses of water into one big bowl, I see that I have 220 units of liquid in the big bowl. So what I'm going to do now is I'm going to redistribute. I'm going to redistribute all of these units of liquid evenly amongst my 15 glasses. So I want to know what number of units should I place in each glass if I want each glass to have the exact same amount of liquid. So what I'm going to do is I'm going to take the 220 units that I have in my big bowl, and I am going to divide that by 15 for the 15 glasses. And upon doing that, I see that each glass, if I want them all to have an equal amount of liquid, each glass should have 14 2/3 units of liquid. So I'm going to begin now pouring 14 2/3 units of liquid into each glass. And there we have it. I've averaged everything out. So now the 220 original units of water or liquid is evenly distributed amongst all 15 glasses. And that is the mean.